Okay, so let's proceed to the second part of the lesson, which is about the domain of rational function. But first, let's try to define what is a domain. Domain of a function is a set of all allowable values of x or independent variable. Now, I want you to focus on the word allowable. What do you mean by that? It simply means that not all numbers can replace x, especially in a rational function. Let's go back to the definition of rational functions. What makes a function rational? You need to have, it should satisfy three things. First, both the numerator and the denominator should be polynomials. Second condition is that the denominator should have at least one variable, which in this case it has one variable. And the third condition talks about the domain, okay? Because in the third condition, our q, which is the denominator, cannot be equal to 0. Okay? Now take note that in a rational function, in the denominator, there is a variable. And we all know what a variable is. A variable can be replaced by any number. But in a rational function, there are certain numbers that cannot replace x. Like in this case. If I'm going to replace x here by 0, this will be equal to 3 over 0. Okay? So the whole denominator cannot be equal to 0. But here, if I will replace x by 0, and you use your calculator and try to divide 3 and 0, 3 divided by 0, use your calculator, it will result in an error. Because this is basically undefined. So in finding the domain of a rational function, all numbers can be used as a replacement of x, except a number or numbers that will make the denominator equal to 0. Let me give you examples. Here we have x squared plus 3x minus 4 over x. Our focus in finding the domain of a rational function is in the denominator. Okay? So our denominator here is x, and I already told you this a while ago that x cannot be equal to 0. Now, how can we write all the numbers, okay, except 0 in a notation? I will start with this arrow here so that you will understand this better. Okay? All of the numbers on the right side are positive until positive infinity. They are allowed, take note of that, except 0. And all of the numbers on the left side are negative until negative infinity. Meaning all of the numbers on the right are allowed, all of the numbers on the left are also allowed, of 0. So that means from 0 to positive infinity. Okay. So we will use this symbol instead of this. Okay, what's the difference of these two symbols? The meaning of this symbol is that 0, if I will use this means that 0 is included in the domain. This means 0, 1, or 0, 0.00001, 0.000002 until positive infinity. So this symbol means 0 is not included. Okay? This means 0 is included. So that's why in finding the domain of a rational function, we will only be using parentheses. Okay? And then from 0 to negative infinity. And of course, we will use this symbol here. So this means the union. We will just combine. That means we will combine all of those numbers except 0. From positive infinity to negative infinity. So this is the answer. Okay, for this. So this is the domain. Okay? How about number 2? Okay? Here we have x squared over negative x plus 3. Okay? So we will do the same thing here. The only difference of these two is that here we only have a term, which is x. Here we have two terms or binomials, which is excuse me, negative x plus 3. So what we will do here is we will write this not equal to 0. Okay, it should not be equal to 0. So subtract 3 on both sides. We will cancel that. Negative x should not be equal to negative 3 divided by negative 3, or sorry, divided by negative 1 divided by negative 1. So x cannot be equal to positive 3. What do you mean by that? Meaning all numbers except positive 3. Can I replace x here by 0? Yes, because it will make the whole denominator not equal to 0. So if this is 0, 0 plus 3 is equal to 3. Okay, our concern is the whole denominator, not the variable. Okay, please take note of that. So using this, it means that this 3, if I will substitute x by 3, this will make the denominator equal to 0. And that's not allowed. Okay? It means that our denominator cannot be equal to 0. If you remember the definition, our q cannot be equal to 0. So what we're trying to do here is identify those numbers that will make the denominator 0 and exclude them. We will exclude them. Okay? So 3, using this arrow, I will locate 3. This is 3. All the numbers on the right side of 3 are acceptable, and all of the numbers on the left side of 3 are also acceptable. So on the left side, it's all negative. On the right side, it's all positive. So we will just be doing this notation. They are almost similar because we are dealing here with one number only. So that's 3 until positive infinity. Union of that, so 3 until negative infinity. So this is our domain. It means that all of the numbers except 3. Okay? This parenthesis means that 3 is not included.